Of course, so we should be live-ish. Seth, I'm sure you recall how this works. We interview you, and then at around the 25-minute mark, we thank you for your time and wish you good luck. And you're free to close the window and go back to searching for aliens.
Well, yeah, I may do that, or I may just lie on the couch and take a nap.
Yeah, either one is fine. I find
Both very productive.
both feel right. How this works, we interview you, and then at around the 25-minute mark, we thank you for your time and wish you good luck.
I hear you.
Yeah, I know. Why am I getting a double? All right.
It bounced back from some nearby.
Someone is playing our video on. Someone.
Both very productive.
Both feel right. Somebody has the YouTube video on right now. So you have to make sure you close that if it's coming out of your... Anyone? Looks like we're okay. All right. Whew, we did it. Technical support. You think...
Maybe... I hear you.
Yeah, I know. Why am I getting a double? All right. Yeah, I still hear it.
Is anyone not wearing headphones?
I think lots of people are not wearing headphones, but I'm going to...
I just saw a couple in downtown Mountain View. But they had little masks on their headphones.
All right, if we hear it again, I guess we will try to chase it down, but I guess we're okay. All right. Yeah. That's so weird. It's definitely not coming from my computer, I think.
You still hear it?
Not anymore. But maybe I'm just hearing voices. Like, am I going crazy? Are you guys watching me go crazy? Maybe that's what it is.
I mean,
did it happen twice?
Yeah, it happened twice.
It did happen twice.
Yeah.
If you're going crazy, you're taking the rest of us with you. So
yeah, okay, good. Yeah, I'm just like, where is this coming from? Okay, I think we're all right. Man, whew, what a week. Wait, we just spent all of this normal chat time. I got to say hello to some people. Whew. All right. Hello to A&T, Adam Synergy, Andrew Planet, Andy Cowley, Benjamin Valamont, Bob Moeller, Brexit Denier, Capital H, Christopher Senti, Corey S., David Dunn, David Fairweather, David Rios Mora, Emmett Ford, Horizon Brave, Ian Farquharan, Jay Brodeur, Johnny J., Kevin Ayers, Larry Beckham, Lionel L., Michael Jobin, Nancy Graziano, Neil Yu, Neko Girl, Noel Ruppenthal, Paranor, Raj Luthra, Rich Wilson, Sergio Botero, Sergusi, The Crankle Factory, The Dying Atheist, Uncle Bill Druin. Hey everyone, welcome to this week's episode of the Weekly Space Hangout. People are saying I've been under lockdown for too long, or not long enough. Whatever it is, I need to be under lockdown for exactly the right amount of time. Okay, well, you know what? We've hit the 5-minute mark. Even though we started a couple of minutes late, I say we begin. So I'm going to put you guys all back in your boxes. There's me. There. And here we go. Hello and welcome to the Weekly Space Hangout for Wednesday, March 13th, 2020. I'm Fraser Kane, publisher of Universe Today. This week, we're going to be talking about even more support for plumes on Europa, the 100th anniversary of the Great Debate, uninhabitable Martian brines, and maybe the naked eye comet that we've all been expecting to see, as well as an interesting idea to intercept new interstellar objects. Joining me this week on my screen, I've got Dr. Kimberly Cartier. Kimberly.
Hey, Fraser. Happy podcast day.
Happy podcast day. Great to see you again.
Yes, it was very, very happy podcast day.
We've got Chris Carr. Chris, welcome back. I think this is your second return appearance on the Weekly Space Hangout, right?
This is actually my third appearance.
This is your third. All right. Well, then you're a seasoned veteran.
Yeah,
excellent.
I know the ropes in and out.
You know all the ropes. You're ready to go. And then we've also got Pam Hoffman. Pam, welcome back.
Thanks, Fraser. Good to be here.
All right. Before we continue on with our show and our special guest, who is it? Who's our guest? I just want to remind everybody that we couldn't do the show without the incredible help and assistance from our good friends at the Weekly Space Hangout crew. These are our fans, but they are also our executive producers, leading us and telling us what to do, organizing the guests, choosing the shows, and really just making the show exactly what they want. So if you want to be in complete control over all of my neurons and to demand who I interview next, you should join the Weekly Space Hangout crew. Go to wshcrew.space. They'll make you an executive producer. You can print your own business cards, and then you can reach out to incredible guests. For example, the guest we have today, return guest, Seth Shostak. Seth, welcome back to the Weekly Space Hangout.
Well, Fraser, it is really a pleasure to get out of the house here for a change.
Yeah, exactly. At least with your imagination, anyway.
My goodness. I mean, I never thought much of my neighbors before, but now I kind of miss them.
Go over and see how they're doing from afar. Well, so for people who don't know, who are you? What do you do?
Well, my name is Seth, Sugar Echo Tango Hawaii, and I actually work for the SETI Institute, which is Sugar Echo Tango India. So it's almost my name. And the SETI Institute is a nonprofit research organization, and it's very brief, which is to say, we're trying to find out if there's any life beyond Earth and to understand that life if we find it, or even if we don't find it, we might understand something.
Now, we were actually, the co-host and I were joking a little before the show that you were actually contractually obligated to inform us first. I believe last time you were on, I said, if you ever find aliens, let us know. You said, sure. That's pretty much enforceable. The fact that you didn't reach out to us either means you're in breach of contract or you haven't discovered aliens.
I seem to have lost my copy of that contract, Fraser.
Right.
Contract. My guys, listen, this much I'll tell you. I mean, I can't tell you everything, of course.
Yeah.
No, this much I'll tell you. If we were to pick up, you're talking about intelligent aliens. If we find, aliens living on, for example, Europa, since you brought up Europa, or Mars, or some of the other, delectable worlds of our own solar system, you can be sure that the media will be covering that within 12 hours. Right?
Yeah.
It's a big story. We've seen that happen.
Yeah, people always say, right? Why would astronomers keep this quiet? They won't shut up about it.
No, of course not. And, people like to think that NASA is keeping secrets. I've never been convinced that NASA could keep secrets, but they certainly have no motivation to keep secrets. If they were to find life on Mars, even if it's only microscopic, of course, that would be the best thing that could ever happen to the agency. But when it comes to SETI is, of course, not run by the government, not funded by the government. But if we were to find something, I can assure you, because we've had a false alarm or two, that the media are on top of the story immediately. And of course, it would also not serve our interest to keep it quiet either. But there's no contract.
No, it's fine. It's fine. It's verbal. It's unspoken. We understand. So what, in the last couple of years, I think since we've had you, are there any new developments in the SETI space? Obviously no discovery of aliens, but for a field that has no discovery, the amount of research and the amount of new ideas is growing at an exponential pace. It's a pretty fascinating topic to be watching from afar.
Well, it's true. There are always developments. People often occasionally will say, well, so doesn't it get a little boring that you're in a field where, you didn't hear anything last week and you didn't hear anything the week before that. And, you might not hear anything this week. Isn't that kind of tedious? And it's not, because of changes such as you allude to. And they tend to be in two categories. To begin with, there's the change in the astronomy. Okay. So there are always new, exoplanets but it's not so much finding new exoplanets. There's been thousands of them found. So that's not really news anymore. But what's news is to learn more about them. And, the new James Webb telescope will help us do that too. So there's always the improvements in astronomy that, tell us whether we should even expect intelligent aliens out there. And all I can tell you about that is that so far, no deal breakers. So far, no bad news. In fact, all the news has been good. There seem to be lots and lots of planets that might have the conditions for Klingons to arise. The second thing, if you happen to like Klingons, and if you're a plastic surgeon, you probably do. The second thing that's different in SETI, of course, is the change in the instrumentation, the use of new equipment, the building of new equipment to speed up the search and make it more sensitive. And there's always news there.
The thing that I find so interesting, and I especially enjoy, like when we were at the American Astronomical Society meeting earlier this year, there was a lot of great talks by people, and they propose ideas that had never even occurred to me. But once you hear it, you're like, that's such a great idea. Of course, that's something that people should be looking for, or a method that people should be looking for. And I think that idea that, when you say like nothing is, there's no showstoppers, no deal breakers. I mean, as we discover more, like now we have observations of an interstellar comet, as well as potentially interstellar asteroid, that you're starting to get just a hint of maybe the larger Milky Way has chemicals that are similar to what we have here in the solar system, and also interesting differences. It's like the more we find out about the Milky Way, the more that just becomes new ideas for us to continue the search.
Yeah, absolutely. I mean, I think perhaps maybe not the greatest, but certainly one of the greatest discoveries of astronomy over the past 400 years is the fact that we now know that the whole universe is made of the same stuff. That was a particular comfort to me, because I was afraid I would have to take chemistry again if I moved to, the other side of the galaxy. Not that I have plans to do that, but, I mean, we've known that for a long time. And now we're finding that some of the precursor molecules for life are very commonly made and present in comets, asteroids, whatever, amino acids and stuff like that make up proteins. They're all over the place. I mean, when people say the universe is set up for life, yeah. I mean, I wish I were set up for life, but you know what I mean? If the universe is set up for life, yes, all the chemistry that's necessary to at least give it a chance to get going seems to be very naturally occurring.
Yeah, and so that's sort of all of those discoveries, as you say, organic molecules, many more planets. I mean, we're now moving into the vast survey phase of exoplanets, where you're not just saying, hey, we found another planet. Now you're saying we've found 4,000 confirmed planets. Soon we'll have millions, eventually tens of millions, and we'll know things in aggregate, right? What are the new research, the new instruments, the new technologies, the new missions that are coming up that have got you pretty excited about being able to expand the search?
Well, one thing is the use of the VLA, the Very Large Array, down in just about an hour west of Socorro, New Mexico, if that happens to be a place you go to often. The VLA, it's 27 antennas essentially on a triangle, not a triangle, but a three-legged pattern there on road tracks. And that is used by radio astronomy, has been since the mid-1970s, actually. And it's used all the time, essentially 24/7. They bring it down for maintenance and to move the antennas up and down the railroad tracks occasionally. But our partners in SETI these days at the University of California, Berkeley, in particular, Andrew Simeon, has arranged for us to use the Very Large Array also for SETI work. Okay. And the deal is, that array is essentially an interferometer. And one of the big advantages of an interferometer is that you can point it electronically. You don't need to move the antennas, every time you want to look at a new source. You can steer it a little bit electronically, certainly within what's called the primary field of the antennas. So that means, somebody is using these things to study a nearby galaxy, whatever. And we can, at the same time, if we have the right equipment there, we can, in fact, be looking in a slightly different place to examine a nearby star system that, we have reason to believe might be a suitable home for them that are aliens. So it's pretty exciting. And, it's a big antenna.
Yeah.
How much time do you get to use the Very Large Array, Seth?
Well, if we can get this equipment built, I mean, it's a question of effort and money, but if you can get it built, then you can use it essentially anytime the instrument's being used, which is to say most of the time, right? It's like any astronomical instrument. You don't want it to just sort of sit there and collect dust.
And so this was part of, I mean, I know there was an agreement last in the fall, I think, in the before four times, that is going to make this sort of collaboration between regular radio astronomers and the SETI group, because there's a lot of data that is being pulled down And I know that they, there's, and I'm trying to remember the details. You, of course, I'm sure remember this better, but the fact that they're making the data in the raw format more available to SETI researchers to be able to start combing through.
Well, certainly the Breakthrough Listen people at Berkeley have been doing that, making the data available. In general, the data that are collected, for example, by the VLA, right, the Very Large Array, those data are the kind that are suitable for whatever astronomy is being done there. I mean, if you're studying galaxies, okay, you want to cover a whole bunch of frequencies, for example, maybe near the 21 centimeter line, if that means anything to you. But, your bandwidth would be like 50 kilohertz or something like that. And you would set up the instrument to get the data in the form you want. But if you're looking for ET, you figure the way you're going to recognize a signal from ET is that it's at one spot on the radio dial. And it might be a very, very narrow signal, right? So you need a different kind of setup, getting different kinds of data. You can't just go through, those guys' data and hope to find something.
Right. And I mean, this is just the beginning. I mean, we're entering this whole new realm of mega instruments. I mean, do you think about the potential for something like, say, the square kilometer array?
Of course. Yeah, of course. I mean, it's the square kilometer array is about a kilometer on a side, roughly. So, compare that to the Arecibo antenna down in Puerto Rico, right? That's 300 meters on the side. So it's 3 times smaller diameter. The square kilometer array, obviously 3 times, that's, 9 times the collecting area, but it's not really because it isn't a filled-in dish. Right. So it's not really all that much more sensitive, but on the other hand, it's, again, an array, it's very big, and that means you can use it simultaneously. If you have the right receivers, you can use it simultaneously for many different projects. So again, I think SETI will get in there in the piggyback mode.
And do you feel, I mean, and there's a great quote from Jason Wright. He was like, people are starting to be okay with the idea of looking for dumb aliens. Why can't we look for smart aliens? What's wrong with looking for smart aliens? And, do you feel like SETI is getting more and more acceptable? Sort of like went from Carl Sagan, took a dive for a while, and now I think a lot more people are willing to speak quite openly and collaborate and have conferences and talk about it again.
Yeah, well, that's a good point. I mean, when I joined the SETI Institute, it was still a NASA project. So it was government money, and that was enough to actually, build equipment and deploy equipment and all that sort of thing. And then that was killed by the US Congress. And I think that the problem is, if you talk about looking for microbes on Mars, people don't make jokes about it. I mean, they might believe they're there, they might believe they're not there. But, they say, okay, that's some sort of exploration, maybe that's worthwhile. Whereas if you talk about looking for intelligence, then they're thinking, oh, little green guys, right? And then it's easy to make fun of. So somebody who just doesn't want to spend the tax money, for example, that's exactly what they did. And then they canceled the NASA program. But the flip side to that is that if you grab the next 6 people off the streets of, Annandale, Virginia, just to name a random place, if you were to do that, I think 9 out of 10 of them would say, well, I'm a little more interested in the intelligent aliens than I am in the Martian microbes. So that's the flip side of this. And I think that NASA was always very supportive of the SETI program. And I think they would still be supportive. It's just that from a political perspective, they have to be a little careful.
So how did that happen that SETI became its own entity when it started as a NASA? I didn't even know that it started as a NASA program.
Well, I mean, it depends on what you mean by started, Pam, because the first, modern SETI search, I mean, people were looking for canals on Mars 120 years ago, but the first modern SETI experiment was done by Frank Drake, the astronomer Frank Drake, who, by the way, is turning 90 this month, actually. Wow. And Frank, and Frank used one of the antennas at the National Radio Astronomy Observatory in Green Bank, West Virginia, a small antenna, 85 feet in diameter. That was back in 1960, okay? And for a long time, it was just, astronomers, they go to the radio telescope, they have I did this myself. You have a few extra hours of observing time, and none of the objects you're interested in are in that part of the sky. So, you just go to a star catalog and you write down a bunch of coordinates and, you take a chance and, it's like throwing the dice when you just walk into a casino and then walk back out. So not much chance that you're going to find anything that way because it's not systematic enough. But beginning in the 1970s, a fellow at the NASA Ames Research Center, it was actually a British a physician, believe it or not an astronomer. He got interested in this idea and convinced NASA that it was worthwhile doing this.
So I'd love to know, at this point, I think a lot of people are very familiar with this idea of the Fermi paradox. So what answer to the Fermi paradox do you find most compelling?
Well, nobody knows the answer to the Fermi paradox.
That's why that's the one that you find most compelling.
Yeah. I mean, Enrico Fermi didn't know the answer, and he was a pretty smart guy.
Yeah.
So that's something. Well, I mean, there's a whole litany. There's really a laundry list of possible answers. One that I particularly like, although I have no idea whether it's right or not, is that I'm sure the universe is, let's just take the galaxy to make it simple. The galaxy is undoubtedly chock-a-block with intelligent beings. I can hardly believe otherwise, because otherwise it makes us too special. I'm always suspect about that kind of an assumption. But it could be that we're in a kind of a backwater of the galaxy. This is not an interesting place, right? And as a consequence, we look around, we don't see anybody. It's like living in, central Nevada. It's not that there aren't any people, but not where you are. So that's one possibility. But I think that maybe the other thing is this. Certainly the search has been very, very limited so far. The total number of people doing SETI in the world today is far fewer than the number of people watching this event, right? That's just a fact. So, that's part of it. And the other thing is, keep in mind, we tend to think of the aliens as being little gray guys that are soft and squishy and, whatever. They're alive. Well, maybe, but, we're developing machine intelligence, and presumably the advanced aliens have done the same. So maybe most of the aliens are in fact synthetic in terms, they're synthetic intelligence. And so our schemes to find them might be missing the mark somehow.
Right. Although then you kind of wonder, where are all the alien robots? But
well, they may not have much interest in visiting me. I mean, I didn't visit the ants in the backyard today, although I could have.
Yeah. I got a couple of questions. So Captain Frantic over on Twitch is asking, is SETI geared towards finding the chemical signatures of life in exoplanetary atmospheres?
Well, some SETI work is. I mean, we have people involved. They were involved with Kepler. They're involved with the successors to Kepler and so forth. So those are people. In fact, the majority of the people that work at the Institute are interested, for example, in Mars. You're not going to find intelligent life on Mars unless we happen to send, your brother there. But you might find life. So yes, a lot of people are involved in that. And for that, of course, they're running on NASA grants and so forth. There's a big effort. That's astrobiology. And it's not just Mars. It's also Callisto, Ganymede, Europa, Enceladus, Titan. There are at least a half dozen places in the solar system where there might be life, but it would be small.
But from a biosignature, from a technosignature standpoint, there are a range of interesting chemicals that could be perceived in the atmosphere of an extra solar planet that could indicate some level of advanced civilization or pollution or what have you, right?
Yeah, you mean like hairspray?
Yeah, chlorofluorocarbons.
Yeah, right. Okay, we don't know what they look like, but they're taking care of their hair.
Yeah, they have nice hair.
Yeah, it could be, but that's a very difficult experiment, actually, because, even if they're in their hairspray mode, and we were for a couple of decades, and that was it, and a couple of decades is nothing compared to the age of the universe, right?
Yeah.
So, you'd have to be very, very lucky to catch them at that. But even so, even if you knew they were going to do it, it's a very, very weak signal.
Yeah.
Much better to look for a radio signal.
Right. Or the atmosphere from cyanobacteria, which may be doing it for 500
looking for oxygen,
years.
Indeed. Yeah.
Yeah.
That's a signal that's been going out from Earth into space for 2 billion years.
Yeah, and that's what I always tell people. People always wonder, should we be sending messages out to space? Well, the reality is the jig is up, right? The cyanobacteria ratted us out 2 billion years ago. So the aliens know we're here already.
Well, they at least know that lettuce is here. Yes.
Yeah, lettuce is here. Sure. Yeah, but lettuce, and then you get, weapons of war. Let's see. So Arjun is asking,
Lovely.
how far away could we detect Earth life through any means available to us now?
Well, you could detect Earth's life. You could detect the fact that Earth has biology anywhere within 2 billion light years if you have a big enough telescope, just by looking for the oxygen in the atmosphere, right? 21% of the Earth's atmosphere is oxygen, right? So, and that's only because of, as you say, the cyanobacteria have been busy excreting it all that time. So, it isn't very hard to find oxygen in the atmosphere if you have a, big enough telescope to get any light. All you need is 1 pixel of an image of the Earth, and you could tell that there's life. But if you're talking about intelligent life, such as, occupies Peoria, then you need, either to pick up a radio, television, radar, something like that, or to have the kind of telescope that we really don't know much about, which would be something with an aperture large enough to see, the interstate highway system or something like that. But then you'd have to be close enough, you'd have to be less than 60 light years away. Otherwise, there was no interstate highway system.
Right, of course. You've got to deal with time as well. Well, Seth, what are you working on now, and where can people find out more if they want to follow your adventures?
Yeah, well, they can certainly find out more by going to SETI.org, SETI.org. And I might remind people also that we have a weekly 1-hour radio show, which is also a podcast called Big Picture Science. And we've been talking about the pandemic a lot recently, but we cover all science.
Especially aliens.
Yes.
Well, always a pleasure to have you on. And again, if you do find aliens, please let us know.
Well, do you have a need to know, Fraser?
If I do. I need to know.
Okay.
All right. Thank you so much. Take care.
All right. Bye-bye, everybody. Bye.
All right. Let's move on to the news portion of the week. Chris, I choose you.
Yeah, I knew I was going to go first.
Did you?
Yeah, I spoke last before Seth came on, so I knew I was going to be first.
Yeah, that's how. Oh, you hacked my algorithm. What? Let's talk about the Great Debate.
Gladly. So I thought I'd get historical for once. So I bring news of a recent centennial. So that's a very important date in the history of astronomy, and it became to be known as the Great Debate. And the nature of this debate was about these peculiar objects that astronomers were starting to observe in greater frequencies when they turned on their telescopes and around the dawn of the 19th century. Because like when you turn on your telescopes, you see stars, you see globular clusters, but there are also these objects that had very coherent spiral structure on them. And they sort of developed the name of a spiral nebula. And it's really puzzled astronomers for quite some time, sort of culminating into this great debate where the topic was whether or not these spiral nebulae are they constituent of the Milky Way or if they exist external to it in the form of some island universe. And I really want to talk about this because I find it very fascinating to look at these sort of paradigm shifts in the history of astronomy, and also trying to look at the arguments from a more modern lens. And so the two central combatants in the debate were two fellow astronomers by the names of Harlow Shapley and Herbert Curtis. And so they're both observers at various observatories. Harlow Shapley was an observer at the Mount Wilson Observatory, and his research mostly focused on globular clusters in the Milky Way, and use that as sort of evidence to justify the Milky Way being a lot larger than what people had previously thought. And he was also on the younger end. He was during the time of the debate, he was in his 30s, but he stuck to the more conventional view that these spiral nebulae were constituent of the Milky Way.
Right.
Right. And so the other combatant was Herbert Curtis. He was more senior. I think he was in his 50s by the time this debate came around, and his research was in the astrophotography of these spiral nebulae, and he held the position that these spiral nebulae were external galaxies. And there's a great description of Herbert Curtis by a colleague, described him as a quiet, smart man with a remarkable sneeze. Yeah, I just love that description of him.
You would have to have heard that sneeze a lot of times to really get familiar with it.
Yeah, also like echoing off the observatory dome and everything.
Yeah, perfect acoustics.
Right, and so the Great Debate, as it's called, was organized by a collaborator of Shafley's. I think his last name was Hale or Gale. I'm not quite sure. And so he brought up this idea of having this debate on the subject of whether or not these spiral galaxies are part of the Milky Way or not, spiral nebulae are part of the galaxy or not. And so the debate was organized on April 26, 1920, at the Smithsonian Museum of Natural History. And according to accounts, the place was brimming
Wow.
with people. Like, there were members of the public, there were other astronomers, and according to legend, Einstein was there, but it turns out that's not true.
Okay.
He was in Europe at the time, so he was not there to witness history. But notwithstanding, it was still a very foundational debate in the history of science. And so they both sort of brought these different arguments sort of to defending their position. And Shafley, the one who was defending that the position that these spiral nebulae were part of the Milky Way, he was relying on these spectroscopic measurements of external spiral galaxies provided to him by a colleague of his by the name of Adrian von Manen. And what Manen had observed with these spiral nebulae is he claimed to observe rotation of these spiral galaxies like within a human timescale.
Right.
And so Shafley used this evidence from his collaborator to show that if these spiral nebulae were indeed as far as you proclaim, or as massive as you proclaim, if they're spinning that fast, their rotational velocities would exceed the speed of light. And so he used that as an argument against this extragalactic hypothesis. The other predominant argument he used was the recent observation of what were called new stars, or by the Latin name novae, in the Andromeda spiral nebulae in 1885. And this one novae event emitted more light than the entire spiral nebulae over its entire lifetime. And so he used this as justification to say, if this was an external galaxy, there's no way this single object could exceed the light emitted from this entire galaxy.
Right.
Because that would have been absurd.
Yeah. A small point source object emitting more radiation than an entire galaxy? Ridiculous.
Absurd. And so these are the two most coherent arguments that Shafley put forward as to why these spiral nebulae are constituents of the Milky Way. And to Shafley's credit, his research on globular clusters was really instrumental in showing that the Milky Way was a lot larger than people had originally thought, because he was detecting globular clusters that are part of the Milky Way at around 50 or 60 kiloparsecs away from the sun.
Now, were they using Cepheid variables at that point, or were they were they using? I mean, you can't use astrometry to get that far away. So they had some distance tools at this point, right?
Right. I don't think it was the Cepheid variables just yet. From what I've read, both of them were very skeptical of using Cepheids as distance indicators.
Right. Well, I believe it was it Vera Rubin was proposing that? Who was proposing it at the time?
Well, this is actually around the time of Hubble, right?
Yeah, so this is like right before, like Hubble was like 26, I think. I forget exactly when Hubble, solved it with science. But these guys argued about it.
Yeah, so Hubble used Cepheid variables to show that the period luminosity relation of Cepheid variable stars to place Cepheid variables that were in Andromeda significantly farther away from anything that had been observed galactically.
Yeah, and matching them up with redshift.
Yes, yes.
Yeah.
Oh, fun tidbit. So both of them didn't understand why these spiral nebulae all consistently showed a positive recessional velocity or a redshift. And so they both sort of made these mental gymnastics to explain why that is. So Shapley tried to explain this because as these spiral nebulae were all being repulsed from the Milky Way due to some radiation pressure, which was complete,
Right.
I guess, slightly nonsense.
Yeah, he made it up.
Yeah, he made it up, and funny enough, there's actually a paper released that year that showed that couldn't be, that was off by orders of magnitude, so that couldn't have been the right answer. And then Curtis, on the other hand, just sort of threw up his hands and say it's an intrinsic property of these spiral nebulae, and didn't seek to give an explanation.
Even though it's a beautiful explanation for what his opinion was, that they are island, you know, galaxies all on their own, and they are speeding away from us. But I guess it's the everything speeding away from us part that was the difficult mental gymnastics to make. Right.
Right, because
that's crazy. Yeah.
So what was the new debate? What are they working on now? You know, this one that just happened.
Oh, well, this was, I mean, we'll bring that up later, but the fact that that a bunch of astronomers got together and held another online version of a great debate where they were looking into the Fermi paradox, which, you know, I mentioned with Seth before. So did they come to an answer, Chris? Did someone win?
So it's funny, when there were like follow-up discussions on this thing decades later, and apparently both said that they won.
Yeah.
But I think a good takeaway from it is that Shapley was even though he had the incorrect position, he was very instrumental in giving the evidence that the Milky Way was a lot larger than previously thought, and that the sun was not the center of the Milky Way. So in that sense, I think Shapley deserves like all the credit.
Right.
And Curtis, his sort of central argument was that you had this sort of over density of novae happening in these spiral nebulae, which would be kind of strange if they were all part of the same universe. Why you're having these sort of preferential placement of these novae, and it turns out is because these are supernovae and they're happening in these external galaxies.
Right. Right.
But I think, like, the last point that I love about this story is that after Hubble like emerged on the scene, and with his luminosity period relation for the Cepheid variables showing that M30, that Andromeda was indeed an external galaxy, he sent a letter to Shapley showing his results, and Shapley, according to a grad student, held up the letter and said, "This is the letter that destroyed my universe."
But I'm sure he was happy about it.
Yes. He also mentioned that he kind of believed Adrian Van Nomen's like observations, and he didn't question them because he was a friend.
Yeah.
He also said,
yeah.
So I think it's important just to have these to just go back in history and see like the progress we've made in the last 100 years, how we went from not knowing whether or not we were the lone galaxy to now emerging into a cosmology of trillions of galaxies that spans billions of years.
Yeah.
At least it makes me hopeful for the next 100 years and for the next great debates of the 21st century.
Yeah, it's interesting to see. I mean, I love these moments where like there's just such a slam dunk of evidence that it just really crystallizes the thinking on some topic. And the Big Bang is the one. When Hubble produced his paper, there was no longer any question about a whole bunch of cosmological questions. And yet just a couple of years before that, they could have this very interesting conversation and not come to any useful conclusion because they didn't have all the data yet to be able to provide an answer. But it's wonderful. And yeah, it sort of makes me feel sad that a couple of astronomers could have this debate in the middle, at the Smithsonian, and have so many people show up and be excited about what they wanted to talk about. Like, it doesn't feel like that would happen anymore. Maybe a But, maybe things will come around. Maybe there'll be an epidemiological conversation that'll happen, and lots of people will show up safely distanced from each other to hear the conversation. We'll see. Thanks, Chris. That was awesome. Pam, what should we be watching?
Sure. Thanks so much. And I love to tell you what's good to do out there. I've got a couple of things. The conjunctions that are coming up, just beautiful. There's a couple in the morning and some in the evening. Also, the comet, and there's some really fun stuff involved with that. So on the 14th is Mars and the Moon, and that'll be in the morning. Then there's a couple that are more telescopic objects. The 16th will be Neptune and the Moon. The great thing about these, though, is because the Moon is so easy to find, Neptune will be easier to see than normal. Also on the 20th, Uranus and the Moon, same thing, with being a telescopic object and the Moon being so helpful to help find that much dimmer object. So
I have never heard anyone describe the Moon as being helpful to find an astronomical object.
Sure it is.
So Pam, I'm not too great with my backyard astronomy. Would I be able to see Uranus or Neptune so close to the Moon if I only have a small telescope?
You know what? I don't exactly know. Oh, yes. Okay.
Yes.
So I looked up with Pluto because somebody asked me that on Facebook, and Pluto doesn't require a fairly large, like 8 to 10 inch. But okay, thanks, Fraser. If you know.
Yeah, so you can see. I mean, Uranus is almost bright enough that you could see with the unaided eye. So it's like magnitude 6. Neptune is a few magnitudes lower, but you can definitely see both as a dot in a small telescope. Pluto is a lot dimmer. I think it's like 15th magnitude, so it's a harder reach.
14.
Yeah, but
would you know about binoculars?
Yeah, you could definitely do Uranus in binoculars when it's
cool.
When it's nice in the sky. Neptune's rougher depending on the binoculars that you have. I mean, binoculars will let you go down to in the 8, 9, 10 magnitude depending on the object. So
and a lot's about your eyes too. I don't know that I would be so good at that.
Well, binoculars are great because they allow you to use both of your eyes at the same time, and so objects that you wouldn't be able to see with one eye or the other eye, you can actually see them with clarity using binoculars, and that's part of the magic of binoculars.
Thanks, Kimberly. Now I know too. That's awesome.
So is this our naked eye comet? Comet Swan?
It depends. All right, so late May, we're possibly going to see it at its brightest. Supposedly you can see it naked eye now. And it's, in fact, the closest approach is today, 85 million kilometers.
That's not close.
Closest approach to the Earth.
Yeah, that's like almost the distance.
I'm okay that it's not that close.
That's like half the, no, you're not. That's half
we
the
have
distance
enough to deal with.
To the sun. No, we deserve a closer comet. That's insulting.
If we did, it might be really bright and a little scary too.
No way.
May the 27th, it will be the closest to the sun. And this is going to be like Atlas too. It could be very bright unless it breaks up.
To
like
death.
Atlas did.
Right.
There was something really cool I found out, read an article, and this comet, as well as 11 others, were not found visually going out and looking at the sky. These were found from SOHO footage.
Yeah.
And really anybody can review that footage and find a comet for themselves. So that's another part of this that's like doable. You can go see it now, and you can actually find new comets with the SOHO footage. This one's moving from the southern to the north, and you're going to want to look at Capella. Capella is going to be the nice bright star that will help you find that comet. Right. It's right around there. And it's going to get brighter, supposedly, unless it breaks up again.
Right. Which it will, because they always do, because we're never lucky.
Right. And let me tell you about the other things coming, because in the evening, there's some really great stuff. Mercury and Venus on the 22nd. On the 23rd, Venus and the Moon, and Mercury and the Moon on the 24th. So they're all going to be kind of hanging out in the west in the evening.
That's
I
awesome.
sure wish you could see Mercury. It's just really neat, but it's going to be near Venus. Venus is going to be available for the rest of this month, getting lower and lower and lower in the sky, and then it's going to be gone until it comes back up in the east.
Fantastic. Lots of good stuff to see.
Wait, so for observing these so for observing these comets, is the tail like clearly visible for these objects?
Oh yeah. Yeah. When you observe them, I mean, it depends on the brightness. So, like when there was Comet Hyakutake and Hale-Bopp, which you may not even been born at the time, but which was the last time we had nice bright comets, you could see the tail in the sky, no problem. It was stunning. But we haven't had a nice bright comet since the late 90s. 98.
And they're all different. They're all different, Chris, because it sort of depends on what is, evaporating away from the comet tail. And it's always opposite the sun, because the sun kind of blows it away from the comet head, the coma.
So sort of on this note, of course, we brought back the virtual star party. We did one on Sunday night. For those of you who joined us, you saw some of the live stream views, but I wanted to just share with you some of the pictures that we took, because they're pretty amazing. I'll share the pictures with my co-host here. But so these are the pictures that Corey Schmitz. So this was the Jupiter image that he took, and this was what we were seeing live, but we were seeing it in black and white, and we were also seeing an infrared view of it. But what's amazing about this is we got the Great Red Spot. We are cursed on the virtual star party to never see the Great Red Spot, and suddenly the Great Red Spot just moved into view, and there it was.
Nice.
We also got an image of Saturn, which was great. We were able to see the Cassini division and all the bands across the planet. But here's the picture that just is mind-bending. And this is an image of the moon. It was like almost a full moon, like maybe 4 days after full moon. And it was shot, Corey shot this image looking towards the edge of the moon, and you got just these incredible crater views. So it was a really good night. Corey had a great telescope running. I had some luck with my observatory as well. And so if you haven't already, we're going to do another star party on Sunday night. We will continue to live stream everything that we could see in the night sky, and hopefully we'll be even a little smoother, and maybe some more astronomers. So as always,
I'll let people know too.
Yeah, that'd be great. Yeah, definitely join us.
Cool.
All right, Kimberly, last but not least, what do you got?
Yes. So I want to talk about Mars, actually. Since if you've been watching since the start of the hour, you would have heard Seth, and if not, after we remix this, you'll about to hear Seth talk about life. And so one of the questions that people keep asking, obviously, is there life on Mars, or has there ever been life on Mars? And we're talking the bacterial kind and not the running around on the surface as an alien kind, of course. And to have life, people want to look for liquid water, because that's what we think that life needs. And so there's been a lot of evidence recently that even in today's cold, barren surface of Mars, there's some evidence for spurious liquid water. But this liquid water is not, just pure drinkable water. It's in the form of very, very salty brines, because that's the only way that water could stay liquid on Mars's surface or near Mars's surface under today's conditions. It's very, very salty brines. So now the question is, can bacterial or microbial life live in these water brines? And the short story is probably not.
Right.
According to recent research, the short answer is probably not. So how they figured this out was using a lot of the data collected from various Mars rovers, and obviously all of the satellites that have been orbiting Mars for so long, studying the chemical compositions of the surface, making very detailed maps of Mars, and using very sophisticated computer simulations. They created this map of where on the entirety of Mars's surface, where brines are likely to form, when they form, how long they last, and what type of brine it is. How briny is the brine? Is it like the type of brine that you would use to marinate a turkey for Thanksgiving? Or is it,
salt water,
so salty that it would burn your skin?
Right.
Type of brine. One is good for life, one is not so good for life. And what they found is that there are some times during Mars's year when about 40% of the surface could have a liquid water brine, but it's only 2% of the year. And the real killer here is that the brines that would form will only be liquid if the temperature is, what was it? It was colder. It's stable as a liquid brine only when it's colder than minus 50 degrees Celsius, which is much colder than any type of microbial life we have found on Earth. None of the life that we found on Earth, we don't think any of that can survive at minus 50 degrees Celsius.
And so you've got
even the most extremophiles.
So you've got this situation where you could have liquid water on the surface of Mars in this briny thing, but it
could be all over the place.
Right, but it's so cold that any life in there is going to be dead. And so this is today, right? So this is like a spacecraft lands.
Today now.
Okay. So spacecraft lands, jiggles some cyanobacteria off of its lander legs. They land in a brine, and even the hardiest tardigrade dies a horrible death.
Exactly. So this is both good news and bad news. The bad news is that most Earth life we know probably wouldn't survive. But the good news is that if there is life, microbial life, fossilized or not, that is there, we know that we probably didn't bring it there ourselves. And looking forward, obviously there are many people who are looking towards new missions to Mars, whether crewed or not. And one of the things that is under serious consideration at NASA and at ESA right now are reevaluating what we call planetary protection rules, which are all the different decontamination steps that any spacecraft that lands needs to go through, whether or not humans can go to a place, and which places on a planetary surface are actually safe to go to. And there are many places on Mars, because we think that these liquid brines exist in many places, that no robotic or crewed mission are allowed to go to. They're under the highest protective status. But all of these rules were made, decades ago. And there's been decades of science to improve our understanding of what and where life can exist on Mars. So as we get better and better understanding that, many forms of life just can't survive, even in the liquid brines that may exist on Mars's surface, it opens up many more areas of Mars for us to explore that we haven't been able to get to before.
Right, because the brines may have been present and people were too scared to land a spacecraft and shake those tardigrades.
There was a story probably about a decade ago when there was a discovery of a potential pool of surface liquid on Mars, not too far from the Curiosity rover. And Curiosity was not allowed to go. And people were like, but it's so close. It would only take, XYZ, however many weeks to get there.
Yep.
We could go check it out. And no, we can't, because it was illegal. You're not allowed to go there. Curiosity was not built for that. It was not decontaminated enough. So situations like that in the future, if we have a better understanding of where life can and cannot live, we can still protect areas that might host life, but then explore everywhere else that we haven't been able to before.
Right.
That's so cool.
It's good news and bad news.
It's good news and bad news, yeah.
But in terms of exploration, it opens up a lot of opportunities. And it gives us it would give us better confidence if we do find something, to know that it is Martian life and not just Earth life that we accidentally dropped.
Yeah. We've got just like a couple of minutes, so can you give us a quick update on Europa's plumes?
I can certainly try in a couple minutes.
Yeah.
So many people know, and one of the moons of Saturn, Enceladus, has large plumes that jet out into space. And there have been some hints that Europa, the moon of Jupiter, that famously has a liquid water ocean underneath, there have been some hints that Europa might also have plumes, which is exciting, because it could deposit all sorts of minerals and new materials on the surface. It could eject things into space and give us a look at the composition of those interior oceans to see if those have life. But there's been no good evidence of that. And the only hints of these plumes come from about 20-year-old data from when the Galileo spacecraft visited Jupiter. And it noticed some weird magnetic anomalies around Europa. Europa was interacting with Jupiter's magnetic field in a sort of inexplicable way. And sort of attributed to plumes, but it's not terribly convincing. Researchers recently went back to those Galileo data and actually looked at data from a different instrument. So not the magnetometer, but the high energy particle detector. to see maybe the plumes, which would have, uncharged water particles spewing into space, maybe those plume particles were interacting with the high energy particles on Jupiter's planetary wind. And lo and behold, they did find some particle anomalies surrounding Europa. And by running it through a bunch of computer models, they figured out that plumes would actually cause very similar particle interactions to what Galileo had seen. So again, it's not direct evidence of plumes, sending a mission there and, taking a picture of plumes or a video of plumes, but it's more convincing evidence that some amount of material from Europa's subsurface ocean is making its way into space.
So don't call off the Europa Clipper mission.
Don't call off Europa Clipper. Don't call off JUICE.
Okay.
We need those missions. Go to Jupiter, please.
Yes, please. Yeah.
Please go there.
Yeah, like
don't get rid of them.
Yeah.
Because we don't know yet.
Yeah, well, every time you see another picture from Juno, you're like, yes, please, more Jupiter.
Yes, I swear, yeah. Every time I see Juno cam images.
Yeah.
No, there's that. The I'm so glad we went to Jupiter and have this mission. And then I always remember that the camera was not originally part of the mission. They didn't want to put a camera
didn't have
on
a camera. Yeah.
And they snuck it on this like little tiny cheap little camera that snuck on the spacecraft at the very last minute, and it's spectacular.
Yeah, so great. Awesome. All right, well, we've reached the end of our show. I was going to mention one quick thing as well, which was there was a really cool proposal that came out of NIAC a couple of weeks ago, and this was an idea for a spacecraft that could intercept a interstellar asteroid or comet. And the idea is that you take a bunch of solar sails, you send them out to the outer solar system where they essentially hover above the sun. They're being pulled in by the sun, but they're pushing away with their solar sails, so they don't move. And then you wait for some next interstellar object to pass in to be detected as it's on its way into the inner solar system. And then the thing trims its sail, falls into the sun, does a slingshot around the sun, and can match trajectory with this interstellar object. And so the proposal is that you build a fleet of these solar sail CubeSats out in various places around the solar system, waiting for one of the next interstellar object to come through, catch up to it, and then start to study it up close. And it would be the equivalent, and here's the key, Kimberly, it would be the equivalent of sending a robotic space mission to an extrasolar planet, because you would literally be studying...
Which one?
Well, you don't get to choose. So, you get to study up close.
Sending a mission to Proxima B is different than sending it to TRAPPIST-1.
Yeah, so you get to analyze, though, the surface composition of an asteroid or a comet that was formed in another solar system. So it would be amazing. And yes, please. And I thought it was such a great idea.
Amazing. I have many questions about its feasibility.
Yeah, and how many are they thinking they would send?
Many.
Big, it's a
big
you'd have to build a whole.
Yeah,
it'd have to be isotropic all over the solar system.
Each one would have a cone.
There's no way to tell where it would come from.
Yeah, so each one would essentially have an interception cone that it could make, and so then when an object
are you
was
saying
detected,
we would need a whole sphere of objects with solar panel-like things around
some sort of
the sun
Dyson
in a
thing.
sphere?
Yeah, exactly. Yeah.
Dyson-like?
Yeah, exactly. Maybe once you have the Dyson sphere, you could also, while you're at it, intercept interstellar objects. I love NIAC. The point is, I love NIAC.
You want to turn us into a Kardashev 2 civilization to intercept an interstellar comet.
We'll do what it takes. We'll do what it takes. Yeah, exactly. Whatever it takes. All right, we've reached at the end of our hour. Chris, you're on my screen. Where can people find out more?
Well, you can follow me on Twitter at @TheRealCcar and learn about what I'm doing and how I'm surviving quarantine.
And if people want to see something interesting, what are you working on right now?
So for my research, I work with Gaia and trying to understand the migrations of stars in the Milky Way. So that's what I'm doing now in my free time.
Yeah, in your free time, that's your next paper.
Oh, I hope.
Yeah. Pam?
Yeah, so I am at Amazon, and my daughter, she's so fun. She tells me, "Mom, you're searchable. Just look up Pam Hoffman, and you should see this book, Your Amazing Itty Bitty Explore Space Now book." I talk about 15 simple ways you can get involved personally yourself.
Fantastic. And Kimberly, what are you working on?
Oh, I just finished up a very long article all about how high energy lasers all over the world are helping us understand the insides of planets. I learned so many very cool facts.
Wow.
Like, yeah, I learned so many very, very cool things
See, so
talking to all these scientists.
I don't remember the press release, so that makes me think that you did some original
No,
reporting. It's
this
just like
is
straight up.
This is an article for a special month we're doing at EOS, all about high pressure, high temperature experiments.
That's really cool.
Yeah.
Awesome.
So you got to talk to so many cool scientists.
And of course, you can be reached on the internet.
On the internet at eos.org and on Twitter at AstroKimCartier.
Wonderful. All right, as I mentioned, we've got, lots of good stuff coming up. We've got a interview on my channel, Open Space, on Sunday morning. Funny time, I know, but I'm going to be interviewing the Royal Astronomer Martin Rees and talking about astronomy and existential dread. So I think we'll have a great conversation. And that's a special time, so I'll put the event into the calendar, and then you can remember that it's happening at a funny time or watch it afterwards. And then another Open Space on Monday night as well, I think. Also a virtual star party, also Astronomy Cast on Friday. So lots of good stuff coming up. Oh, and we've got another episode that's going to be coming out from the Guide to Space. So lots of great stuff coming. All right, I'm going to put everybody into their boxes. Thank you, everyone, for watching this week's episode of the Weekly Space Hangout. I really appreciate your support and your eyeballs. We've got both to everyone on YouTube and everybody on Twitch. Really appreciate it. Thanks to all of the moderators, the people who are simulcasting this show across all of the various competing live stream broadcasting services. Special thanks to Nancy Graziano and everyone there. All right, everyone, we will see you all next week. And thanks to Seth. That was awesome.